Hello, and a very good morning to Dr. Shahrudin, our beloved physics lecturer, and also my fellow friends. Our group's APEC project is going to be about solar vacuum cleaner. Our group consists of Nur Akmar, our group leader, one Muhammad Fahmi FAIQ, is QISTINA BATRISYIA, and myself, Shashi Kumar.
Have you ever wondered how a vacuum cleaner works? It's not magic, it is physics. Let's take a closer look at the science behind it. Inside the vacuum, there is a motor-driven fan that spins rapidly. This movement reduces the air pressure inside, creating a low pressure zone. Now the air outside the vacuum is at a higher pressure. This difference in pressure pushes air and anything in is passed into the vacuum. Along with the air, dirt and dust particles are carried into the vacuum. Once inside, they are trapped by filters or collected in the chamber. So to sum up, this entire process works because of the pressure difference. The motor keeps creating a low pressure area and the atmospheric pressure keeps pushing air and dirt through the vacuum, making it an efficient cleaning tool.
Next up, let's look into suction formation and Bernoulli principle. First up, we have the Bernoulli principle. As air velocity increases through a constriction, the static pressure decreases. This creates a low pressure region that aids in lifting or gripping objects. Compressed air escaping through small holes in the suction cup is accelerated, further reducing pressure and contributing to the vacuum effect to the region A. The accelerated air escapes laterally in region B, creating an air cushion. This cushion minimizes direct contact with workpiece, ensuring delicate handling, which is ideal for porous or fragile items. The high flow rate compensates for any air leakage, allowing the system to maintain functionality even with porous materials. Third, we have the particle removal and drag force. Airflow generated by a fan creates a suction that not only lifts workpieces but also carries dirt or particles into the vacuum cleaner. This is due to drag force, which airflow excess force on particles pulling them along. Finally, we have handling of porous materials. Porous objects that might allow air to pass through are still effectively managed because the system compensates with high airflow, ensuring sufficient suction despite leakage.
Next is conservation of energy. So our group use solar panel as one of our component for our project. So the solar panel will absorb the solar energy from sun and convert it to electrical energy. From the electrical energy, it will convert the electric motor from electrical energy to kinetic energy. How? So the electric motor will rotate the fan to move the air for the generation of stream of the airflow. From the kinetic energy, it then will convert to heat energy. So the some heat energy are lost due to the heat motor and the friction.
Next, I'm going to talk about filtration and particle separation that we are going to do on our project. So for filters, we are going to use HEPA filters. So what is actually HEPA filters? So HEPA is an acronym for High Efficiency Particulate Air, whereby it is highly effective, capturing 99.97% of particles as small as 0.3 microns. So that means this filter can filter a really small particle. It is essential for removing fine dust, pollen and allergens, making them ideal for allergy sufferers. Other than that, we are going to use for our particle separation, we are going to use cyclonic separation. So what is cyclonic separation system? This system basically uses centrifugal force to spin the air inside a chamber. Heavier particles are flung to the side of the chamber and settle at the bottom, while cleaner air moves upward. By removing large particles through centrifugal force, the system reduces the load on traditional filters, allowing them to last longer. This also makes maintenance easier and more cost effective since filter don't clog as quickly and require less frequent replacement. Next, I'm going to explain about factors affecting suction power. So the first one, to enhance its power, we need to ensure that all joints and seal are tightly connected. This causes the system maintains its design pressure gradient. The efficiency of particle removal increases when the pressure drop is higher. However, a pressure drop requires high energy. This leads to our second factors, which are motor power. A stronger motor power creates a greater airflow because it can produce more power to drive the fan or impeller inside the vacuum. For example, a more powerful motor spins the fan faster. Faster spinning creates a higher pressure difference between the vacuum's interior and outside air. And the last one is adjustable nozzle. So smaller openings can focus suction, increasing pressure differences at the nozzle. For instance, a narrower nozzle. For instance, when the nozzle opening is reduced, the air velocity increases due to the effect, creating a stronger suction at the point of contact. This is especially effective for cleaning deep surfaces or picking up heavy debris. Other than that, good angles help airflow smoothly, using less energy, and improves dust collection performance.